Here we take a look at the reaction that is a conversion of alcohols into alkyl halides. And the main purpose of this reaction, which as we're going to see is essentially, at least at the end, just an SN2 reaction, is that alcohols as functional groups are very common in organic molecules. But sometimes we need to convert that oxygen into other things. And OH minus itself is a bad leaving group. And so through the use of a reaction like this, which either by using PBr3 will convert our alcohol into a bromide, or thionyl chloride, SOCl2, we can convert it into a chloride. That then gives us a product that's an alkyl halide, and we can easily use for substitutions or eliminations or even making a Grignard. So how do these reactions work? So in the case of PBr3, we have a phosphorus which is attached to 3 highly electronegative element halogens. And so that's going to make that phosphorus a good electrophile. And so the oxygen attacks the phosphorus, and we kick off one of the bromines. The entire purpose of this step is because OH is a bad leaving group. But once we've attached it to the oxygen, we've made it into a much better leaving group, or attached it to the phosphorus. And so now that Br minus that we just kicked out adds in and does what is essentially an SN2 reaction to make the alkyl halide. The thionyl chloride reaction works in a very similar way. Again, this sulfur, which is bonded to an oxygen and 2 chlorines, is going to be highly electrophilic, and so the alcohol can attack it directly. That intermediate, the O minus, will add its electrons back in, kick out a chlorine. And again, as we did in the bromine case, we've turned the alcohol into a better leaving group. And so now that chloride that attacked can come and do an SN2 reaction, kick out the alcohol, and we've successfully made an alkyl halide from our alcohol.